this video. Here we'll be learning about points of intersection and calculating intersection points of two equations and considering their graphs as well. So in this first example, we've been told that on the same diagram, sketch these two curves. We've been asked to sketch these two curves, and if you think about it, this is a quadratic that has two roots. One root is at x equals to 3, and the other root is at x equals to 0, because you could think of it as bracket that is got x plus or minus 0 next to it, right? 0 doesn't change anything, does it? So that's what it is. So if we think about the coefficients of x, they're both positive, therefore it will be a smiley face. So it will have to go through these 2 points here, and it will look something like so. Then, considering this next, because the coefficient of one of the x's is negative, then it's a negative cubic curve. Let me change my pen color so you will see it better. So a is negative. This is telling us that one of the endpoints is this point, in this quadrant here, where x is positive, x is negative, y is positive, and the opposite effect. When x is positive, y is negative. Alright, so how do we know the roots? Consider this point to be 0. So x equal to 0 is repeated root, and x equals to 1 is a natural root. So that means that it will have to come from here, go through point 1, but because of the repetition, it will make a U-turn at 0, I'll bounce up here. Alright, so then the next part of the question, this is just going through the example, what I've drawn by hand there. I believe the question is asking us to actually solve this equation now. Yes, so it's saying find a solution where f of x equals to g of x. So now it's saying that these two functions, at what point they are equal to each other. So when you set them equal to each other, right, and expand the brackets, you'll have this situation. So you collect them all on one side of the equal sign and set it equal to 0. So you end up with this expression here, x cubed minus 3x. The positive x squares cancel away, right? So now if we can factorize this expression here, there is a common factor of x. We write with x squared minus 3 inside the bracket. This is telling us that one of the solutions is x equals to 0. The other solution is where x squared is 3, therefore x could be plus or minus 3. Right? So, and if you check it, yes, the graph does cross the two lines here, crossing at this origin, the point where is origin. One of the other intersection points is where x equals to minus root 3, and the other intersection point is where x equals to positive root 3. Alright, that's telling you where we found the intersection points by setting the equation or polynomials of each function to each other. Right. You can also figure out the y value by substituting back values of x that we found into either one of those equations. So when x is 0, y is 0 because of this x at the front. So y will be 0 when x is 0. This is telling me about the origin. I kind of knew that they will cross at the origin because of the repeated root business. And when x is positive, root 3, I'll show you the substitution. So when x is negative root 3, we'll have y value to be actually positive, and when x is negative root 3, we'll get y value that is x is positive root 3 and y value is also negative. Right, no, y value is negative. 3 minus root 3 is a negative value because the second part is bigger. So, alright, so let's see what the question is asking in this part. The questions has changed slightly. If you're not sure, just read it carefully. It says that sketch the following curves. We know this is a reciprocal curve and it will have one part of it in this quadrant, the other part in the other quadrant. Doesn't have to be perfect, but it does have to make sure when you draw your um, asymptotes, asymptotes are important, and you actually don't go back on yourself. The line, like I made the error here, it's important that it doesn't go back onto itself. When it has to have one direction only. Like I, this point, there was a mistake here. Make sure you do your sketch with the pencil, and make sure you can so that you can rub it off if something goes wrong. You can correct it. Right. So when this curve goes up, it's not gonna make a U-turn and go back down. Reciprocal curves are important. If you do get a question that you have to sketch them, make sure your sketch is nice and neat. So now this is telling me one of the roots of the cubic is 0 and repeated because it's squared. So make sure you make a note that this root is repeated and this x equals to 1 is not repeated. So, and the coefficients of x cubed is positive, right? A is positive here. Therefore, I will have, let me draw it in a different color. For this part here, I will have it one end of the graph in this quadrant, the other end of the graph in this quadrant here. Now go back and notice the roots. This point is where it's repeated and this is where it's going through the curve. So it has, once this line comes down here and goes through 1, x equals to 1, then it has to make a U-turn and at the origin it has to bounce back down again. So there you go, like so. Now that's how you sketch the curves. Let's see what the question is asking us to do. Next. So we've been asked to write the suitable equation which would give you the x-coordinate of the intersection. So the intersection of these two points here, two graphs, is where this equation is equals to that equation. So we write them equal to each other. We write x squared x minus 1 in a bracket is equals to 2 over x. And we can subtract 2 over x from both sides. We end up with that equation down there. This is what you need to write. Alright? So good luck practicing, and I'll see you in the next video where I'll explain the graph translations.